So last time we looked at how I/O works in Haskell. And we saw that we have a bunch of, for example, primitive functions, basic functions that allow us to operate on things relating to the operating system. But I mean, the core idea behind all this is that we separate the concept of operations which may have side effects from pure functional computation. So that unless something has I/O in it, unless something is an I/O, unless something declares that it has side effects, then we know that operations in Haskell, functions and so on, are real functions and they don't have side effects. So we can build effectful things which have an effect on the outside world, things with I/O around their type, using some basic operations and building larger I/O functions using do notation. For example, here's an example for an operation for copying a file from one place to another. So it has two arguments, the from file path and the to file path. They're just strings that name the from and the to file. And it uses the I/O operation read file, which given a file path will produce the contents of the file but by performing I/O. So that's to say it's an I/O string. This thing is an I/O string. It produces a string by reading from the file system, by performing some I/O. And if we want to use that string, the only way we can do that is by extracting it, as it were, by calling that string a text in this do block. And that guarantees that because we can only do this in a do block, we never escape from the fact that we are performing I/O. We can never hide the fact that we've performed I/O. Because if we could, then we could have hidden side effects. And we don't have hidden side effects in Haskell. So you may remember from that slide that we had an operation called getLine, and getLine was an instruction for reading a line from the standard input. So getLine will just wait for you to type something in the return character, and then it will read that, and its type will be an I/O of string, where the string will be the line that it's actually read. So let's use that to build a function, an instruction, an I/O thing called getName, which will ask the user to type their name and return that as the result. So this will also be an I/O string, and we can define it fairly simply. GetName will be a composition of things. The first thing that it will do is to print something on the screen, and I think I'll just print it as it is. Please type your name. And then it will perform a getName. So the type of, when you build a do block, the type of the do block will be the same as the type of the last line of that do block. And since getName is an I/O of string, sorry, not getName, I meant to write getLine. Since getLine is an I/O of string, then the type of the whole do block is an I/O of string, and the other lines will also be I/O lines, but not necessarily I/O of string. Okay, so that was a little example and a fairly straightforward one. Now let's go back to an example we looked at earlier when we talked about the fact that instructions can be first-class values. So that means we can build things like control operators ourselves. These are functions which take instructions as their arguments. So do twice is such an example. And what does do twice do? Well, you give it some instructions and it runs them twice. The first time it runs them, it'll call the value that you generate A. The second time it will call the value B. And then the value that it delivers will be the pair of the A and the B. So before we actually remember the getName instruction, when we execute getName, this is a special case when the Haskell interpreter gets something of type I/O of something, then it will actually run the instructions. So here it's running the instructions, and I can type my name, and then it will also print out the value that is returned, so that we can actually see what it's doing. So now let's use the do twice operation on our getName. So what does it do? Well, it runs the instructions twice. So here's the first time it's running it. And then it builds the result, which will be the pair of the result from the first time it ran the instructions the second time, and that's the pair that it constructed. So what's the type of that whole thing, that thing that we just did? It looked like a pair, but of course it's not a pair. It's instructions for producing a pair, because it doesn't just generate the pair. It has to interact with the outside world, namely me in this case, and the standard input-output channel between me and GHCI. So what type does this do twice have? Well, in this particular example, we gave it an IO of string, and it gave us back this thing here, an IO and pair of strings. So we gave it the getName function, and when it ran, it ran that thing twice and generated a pair of strings. So that was one possible type that you could use for this. But in fact, it will work for instructions producing anything you like. So we can make this polymorphic. For example, we could apply it to something really boring like putstra. We can print something on the screen. It will print it twice. There it goes, and return the two values. What are the two values? Well, this is an IO of unit, so it returns the two copies of the unit. Pretty useless, but still, it can be done. Okay, that's all very well, but what type does Haskell say that it has? What does GHCI say? What is the type of do twice? In other words, what is its most general type? So that would be an OK type that I provided, but what is the most general type? It turns out that not only can you use any kind of argument, content you like, it could be an IO of string, it could be an IO of unit or whatever, but it actually works not just for IO, but for other kinds of instructions, so to speak. And we can think of this class of instructions, at least for today's lecture. The class of instructions is something called monad. So we're going to think of monad for now as a class of different types of instructions.